Hello friends, I am Dr. Marathe from Department of Microbiology. Today we will discuss about the vitamin, that is vitamin B1 thiamine. In our previous lecture or earlier lecture, we had a thorough discussion on vitamin, its introduction, why the name is given, its nomenclature, classification, different types, everything. Okay, so according to their classification, vitamins are classified into fat soluble vitamin and water soluble vitamin. Okay, water soluble vitamins are further classified into non-B complex and B complex. So B complex, they are further divided into vitamins which are involved in energy releasing reactions, and second type is called as hematopoietic. So today I am going to explain the vitamin B1, which is the representative example, or this is the first vitamin from this B complex series, that is vitamin B1. This vitamin B1 is known as thiamine, Thiamine, thiamine. This thiamine is vitamin B1. This vitamin is an example of water soluble vitamin. This is the vitamin which participates in the enzymatic reaction, okay, in which energy is generated or energy is released. That's why it is classified under the title B complex and energy releasing vitamins. So it starts with the first vitamin, that is vitamin B1 thiamine. This vitamin is also known as anti-beriberi factor, anti-beriberi factor, or this is also known as anti-nuretic factor. Okay. Now we are going to learn these vitamins with respect to the following points. First one, its introduction, little bit historical background, then the main part, that is chemistry and structure, then after structure, chemistry, then dietary sources, then recommended dietary allowance RDA, then deficiency symptoms, and last one and the most important point of this vitamin classification, why we study these vitamins, that is what is its actual biochemical role. Okay, now in the introductory part, as I said, this vitamin B1, it is a thiamine. See, don't forget the spelling. It is THIA, and that THY is what? A part of nitrogenous base. Okay, so that is thiamine, which is a pyrimidine. This is THIAMINE, thiamine. This is a vitamin. So don't get confused in the spelling of thiamine and thiamine. Okay, so regarding the introduction of this vitamin, as I said, it is called as anti-beriberi. It's a beriberi means it's a group of symptoms which arise when the deficiency of this vitamin occurs, and anti-nuretic, involved with the central nervous system or nervous system. This was the introduction. Regarding the historical background, the scientist Lohmann, Lohman, and Schuster in 1937, first of all, they isolated the coenzyme form of this vitamin called as thiamine pyrophosphate from yeast. from East in 1937. Okay, this is regarding the historical background of this vitamin. Next one is what? Chemistry, which is the most important part and that we must understand. So this is made up of three components actually. Vitamin B1 or thiamine is made up of three components. These three components are: one, it is called as pyrimidine ring, means it contains pyrimidine ring, it contains thiazole ring, and third one, it contains pyrophosphate. So all of these are involved in making the coenzyme form of vitamin B1, that is thiamine. It's called as a thiamine pyrophosphate. So what is the actual structure of this vitamin that we'll see? Okay, so it contains a pyrimidine ring. So this is not actually a true pyrimidine ring. It is here it contains, it possesses amino group NH2. Okay, then here it is CH3 methyl group is there. Here nitrogen, here it is nitrogen. Okay, to this a bridge is called as, it's called as a methylene bridge. It's not a CH3, it's a CH2. Then this is attached to nitrogen of this ring. Nitrogen of this ring, okay, it contains sulfur atoms. This ring is called as thiazole ring. Okay, now this is what the reactive carbon. This is the site where the actual reaction occurs during the enzymatic process. This CH3 methyl group is there. Okay, and here it is CH2OH. This is the actual structure of vitamin. So you can say this is what a pyrimidine ring. This is what a thiazole ring. A pyrimidine ring and a thiazole ring. Both rings are linked together by this bridge. This is called as methylene bridge. Okay, means these two rings are linked together by this methylene bridge. Okay, now this is what the basic structure of thiamine. But this structure cannot alone, or it cannot function as a coenzyme in the enzymatic process. Okay, this is the vitamin, it acts as a cofactor, but its coenzyme form is different. This coenzyme form is synthesized from this reaction, this compound, okay, by phosphorylation process. Means ATP, when it reacts with the ATP, from the ATP, pyrophosphate group is removed. From ATP, pyrophosphate group is removed. That pyrophosphate group is linked to this, means the esterification of this hydroxyl group occurs and it links OP. Here it is OH. So you can see the pyrophosphate. Okay, so this pyrophosphate ring is there. Pyrophosphate. Okay, so you can see the structure, whole structure, the actual structure of the vitamin, its coenzyme form is called as TPP. The long form of TPP is thiamine pyrophosphate. So thiamine pyrophosphate contains pyrimidine ring, then thiazole ring. It is linked by methylene bridge. Okay, so this hydroxythiazole ring. To this hydroxythiazole ring, what is attached? A pyrophosphate, which is derived from ATP. Okay, and this whole structure is called as TPP, thiamine pyrophosphate. This is the actual structure. and during the reaction we simply write what TTP, but during the reaction with this carbon the reaction occurs. The reaction occurs means it is involved in what? The reaction process is called as co-carboxylation. Carboxyl group is removed. Okay. Now this is regarding the structure. Then dietary sources. Which are the sources from which we can get this vitamin thiamine? Those vitamins, those dietary factors, these are like cereals, pulses, oil seeds, nuts, then yeast, then pork, liver, heart, kidney, and milk. Milk is another source of this vitamin. So these are the dietary sources. So we should consume these dietary sources to get this vitamin. Actually, this vitamin is present. This vitamin is present in the rice polishings. Okay. So rice polishings, when the rice polishing occurs or rice flourishing, okay, which contains this vitamin, after a polishing that coating is removed, and due to that there is a loss of this vitamin. Okay, and as it is a water soluble vitamin, so during the cooking, what happens? The extraction of this vitamin occurs in the water, and we usually throw that water. Actually, that water should be used in the cooking process because that is a good source of vitamin. Next point is what? RDA, recommended dietary allowance. What should be the minimum concentration of this vitamin in the diet? Okay, the minimum concentration, it is 1.2 to 1.7 milligrams per day. It is 1.2 to 1.7 milligrams per day for normal healthy person. Okay, in case of children, the concentration it may be low, that is 0.7 to 1.2 milligrams per day, and the higher concentration is required by a pregnant or a lactating woman, that is near about 2 milligrams per day. So this much concentration should be inside the body after taking a diet or after getting a diet. Okay, so that is essential for the reactions or for the maintenance of the reactions during 24 hours. Next point is what? Deficiency symptom. If we can't get this much concentration, or if the negligible or if none concentration is there in the diet, and we feel the deficiency of this vitamin in the body, so the body shows some symptoms. Those symptoms are collectively known as beriberi. As I have written here, beriberi. So beriberi, it is a collection of symptoms which includes one, that is anorexia. Anorexia means loss of appetite. Okay, then weakness, weakness, weakness. Nausea, nausea, nausea. Another major symptom, that is constipation. Okay, so proper digestion is not there, it is called as the indigestion, so constipation. Another symptom which is associated with the nervous system or central nervous system, that is called as a mental depression or mental confusion. And last is what? Irritability. Okay, and sometimes we feel the numbness in the legs. That is also due to the deficiency of this vitamin B1, which is called as thiamine. And the last component, which is very important part of this vitamin, is known as biochemical role of thiamine. So we have the role of this vitamin in biochemical reactions, because that is very important to understand why vitamins are essential for growth and maintenance of the cell or life. Okay, so it is actually a cofactor required for one of the enzyme. It is known as PDH. PDH, all of you know that this is a pyruvate dehydrogenase which is required for conversion of pyruvic acid into acetyl CoA. Okay, pyruvate to acetyl CoA. That is called as a PDH complex, which converts pyruvate to acetyl CoA. This PDH complex is not a single enzyme; it is a multi-enzyme complex, and it is made up of 3 enzymes that I have already explained in my another video, which is uploaded on YouTube. That is PDH complex role. Okay, so that PDH is made up of 3 enzymes. First one, it is called as pyruvate dehydrogenase itself. Second is known as dihydrolipoyl dehydrogenase, and third one is known as dihydrolipoyl transacetylase. Means first pyruvate dehydrogenase, second is dihydrolipoyl transacetylase, and third one is the dihydrolipoyl dehydrogenase. These 3 enzymes, they require 5 cofactors. The 5 cofactors are TPP, second lipomide. First one is called as a TPP, second is known as lipomide, third one that is coenzyme A, COASH, fourth one it is called as FAD, flavin adenine nucleotide, and second and last one is known as NAD. Actually, with respect to this vitamin, we are interested in what the first cofactor, that is thiamine or thiamine pyrophosphate, which is a coenzyme form of thiamine. So how it is involved in this reaction that we will see. So during the conversion of pyruvate to acetyl CoA, what happens? Pyruvate, we will draw the structure of pyruvate. It is CH3, C-double-bond-O, COOH. This is pyruvic acid. This is pyruvic acid. Now this pyruvic acid, during the reaction, there is a decarboxylation, and here I am showing TPP, that is thiamine pyrophosphate, okay, which is a part of the first enzyme. It is called as PDH, pyruvate dehydrogenase. So this thiamine pyrophosphate, it acts as a coenzyme for this enzyme, thiamine pyrophosphate. It removes the carboxyl group in the form of CO2. And what remains? It remains CH3, COH, TPP. This is called as hydroxyethyl TPP. This is known as hydroxyethyl TPP. Now, during the next reaction, what happens is another cofactor. As I said, 5 cofactors are required. Another cofactor, that is lipomide. Okay, so this lipomide contains a disulfide linkage. Okay, so same enzyme is involved in this reaction, but this time it is using what? The another cofactor, and this lipomide, okay, it becomes SH. C-double-bond-O, sorry, S is there, S, C-double-bond-O, and CH3. So what happened? This group is transferred from this TPP to lipomide, okay, and it gets reduced due to the breaking of what? Disulfide linkage, and for gain of hydrogen atoms. Okay. In the subsequent reaction, another coenzyme works, that is COASH, coenzyme A. Okay. Another cofactor, it is essential for the next enzyme, and that enzyme is called as dihydrolipoyl transacetylase. This is known as dihydrolipoyl transacetylase. Okay, so this transfers this methyl group on coenzyme A, and that becomes CH3, C-double-bond-O, COA, CS3, C double bond O, SCOA. That is called as acetyl CoA. This is known as acetyl CoA. Okay. Now you have seen how this pyruvic acid is converted into acetyl CoA. But whatever the lipomide, it is reduced. It must be oxidized. So that lipomide it becomes SH and SH. It must be oxidized, and this oxidation is carried out by the next cofactor, that is FAD. It gets reduced to FADH2. Further, it is oxidized by NAD. It gets reduced to NADH plus H plus. So this way, this is the representative reaction where we can show the role of this coenzyme thiamine pyrophosphate in converting pyruvic acid into acetyl CoA. So the similar type of multi-enzyme complex is also involved in the TCA cycle, where the reaction occurs. That reaction is conversion of alpha Kg, alpha ketoglutarate to succinylcholine CoA. Same type of multi-enzyme complex is there. There also requires what? This PDH complex. This is also required by the trans-ketolase enzyme. Okay. So this is everything about what this vitamin B1. Hope you must have understood. Thank you very much.